Hey everyone, welcome to my channel. In this video, we are going to learn how to detect 468 different landmarks on faces. We will use the model provided by Google that runs in real time on CPU and on mobile devices. If you would like to create real-world computer vision apps, do check out my premium course in which we learn how to create apps such as object detection, augmented reality, document scanner, and a lot more. The link is in the description below. So without further ado, let's get started. So here we are in our PyCharm project, and we have created a new project called Face Mesh Project. Now we have a special folder here by the name videos, and if you go inside you will see that we have a couple of videos, in fact more than a couple. You can see here that we have a total of 8 videos, and each of these videos, they have a different size. So they are not actually the same width and height. You can see this one is smaller. So the frame rate might vary based on the size. So let's try this one. Yeah, this one is I think this one is HD or even full HD probably. So yeah. So these are some of the videos that we are going to test on. So what we will do is we will right click and we will create a new Python file, and we are going to call it Face Mesh Basics. So what we will do is we will learn the basics, and once we know the basics, we are going to create a module out of it so that we don't have to write it again and again for different projects. So the first thing will be to install our libraries. We will go to File, Settings, and the Project Interpreter, and we will add the OpenCV Python, and we will also add MediaPipe, which is the library provided by Google that we will be using to detect all these different 400 plus points on the faces. So one of them is already done. The other one is also done. Great. So now we are going to import CV2, and then we are going to import MediaPipe as MP. And then we will also import time to see the frame rate. So as always, the first thing we will do, we will run our video, and we will use cap is equals to cv2.video capture, and we are going to give in our video path. So here it is in videos /1.mp4. Let's use the second one because the second one has 2 faces in it, so that will be better when we are testing. Okay, so then we are going to write while true, we are going to say success and image is equals to cap.read. We are going to read our image, and then we will say cv2.imshow. We will say that it is an image img, and then cv2.wait key as 1. So that is pretty much it. So let's run it and see if it works. And there you go. So you can see the video is now running, and we have 2 faces. The first one, I believe, has only 1. Yeah, and it is quite big. So it is, I think, HD. I mean full HD. So let's work on number 2, and later on, once we are done, we can try number 1, number 3, 4, 5, and so on. Okay, so the next thing we will do is to write the frame rate. So here we are going to write ctime is equals to time.time, and then we are going to write fps is equals to 1 divided by ctime minus ptime. So p stands for previous, c stands for current time. So then we will write that our previous time is equals to current time, And up here we are going to define the previous time is equals to 0. So that should give us the frame rate, and then all we need to do is we need to put it on our image. So we will write put text on the image, and we are going to write FPS, and in the curly brackets we are going to write integer of FPS. And yeah, that should be it. And then we have to give in the location, so 2070, and then we will give in the font cv2.font. Let's give it a plain font. And what else? Then we will give the scale, then the color we will keep it as green, and then we will give in the thickness. So yeah, that should be enough. So let's try that out. And there we have it. So now we are getting the frame rate. It is quite high at the moment. Okay, so that is pretty good. We can bring this down. Now the next step would be to use our media pipe library to actually find the points, the different points on the face. So what do we need? First of all, we are going to write here mpdraw is equals to mp.solutions.drawing utilities. So this will help us draw on our faces. Now we could draw ourselves as well, but the thing is that when they are using their own function, they actually make some lines in between, some connections between these points, and that is quite complicated. So rather than doing it manually, we could use their function for displaying purposes. But if you just want to see the points, you can just draw circles by yourself as well. I will show you how to do that as well. Okay, then we are going to write mp face mesh is equals to mp dot solutions dot face underscore mesh. So we will be using this to actually create our face mesh. So we will write here face mesh is equals to mp face mesh dot face mesh. I know it's quite a bit of repetition, but this is what we need to actually create our object, and from where we can actually find our faces. So then inside this, if I press the control button and I click on this, it will take me to the function itself, to the class face mesh, and here it will tell me that what are the input arguments. So here we can see it's static image mode is false, then we have the total number of faces, then minimum detection confidence and the minimum tracking confidence. So the static image is whether you are using it only for detection or you are using detection and tracking. So if it is a static image mode, it will always detect in each and every single image. But if it is false, then it will detect and then it will track. So detection is always heavier than tracking. So therefore, we will detect first whenever the confidence is above 0.5, which means that it has found the probability of 50% for a face. Then we are going to detect, and then we are going to keep tracking that face if the tracking confidence is higher than 50% as well. So we can change these parameters as well, but for now we are not going to do anything here. Actually, we can change the maximum number of faces because we want to detect 2 faces. So here we can write max number of faces is equals to 2. The rest we can keep it as it is. So then we are going to go down here, and this actually accepts, this class actually accepts only an RGB image. So we have to convert it. So here this image is BGR, so we will convert it. So we will write image RGB is equals to cv2.cvt color, and then we will write image cv2.color underscore BGR to RGB. So that is the idea, and then we can simply write results is equals to face mesh dot process, and we are going to send in our RGB image. So that is the idea. And now what you will see is that the frame rate has dramatically reduced. There you go. So now we are getting right 50s to 60s, which is actually quite high considering that I'm only using CPU. But if we do it on the first one, it will be slower because that is a full HD video. Yeah, so it's around 40s. And if we are doing it on an HD video, then it is around 60s. So that is pretty amazing. Okay, so that is good. And now we are getting some results, but now we need to display them. So to display them, we are going to write if results dot multi-face multi underscore face underscore landmarks. Then if something is detected, then we are going to go ahead and draw. But the thing is that you can have multiple faces here. So you need to loop through the faces before we actually draw. So to do that, we will write here for face landmarks, let's say face landmarks, in results dot multi underscore face underscore landmarks. We are going to go ahead and loop through that, and for that we are going to now draw. We will write here mp draw dot draw landmarks, and then we are going to give in our parameters. So if we go over here, you can see that you have the image, you have the landmark list, you have the connections. So here, first of all, we will give in our image. Then we have the landmarks, which is basically your face LMS. These are the face landmarks. And then the connections. So we are going to write mp face mesh dot face connections. So let's try that out. Let's move it a little bit here. Okay, let's try that out. And there you go. So as you can see, now we are getting the faces, and both the faces are being detected. And if you go back and you write here 1, you will see that only one face is detected. There you go. And you can see how fast and accurate that is, which is pretty amazing to see. Okay, so what if you want to change the size of, let's say, the thickness of the circles or the thickness of the lines around it? So what if you want to do that? Well, to do that, you can write here some specifications. So you can write here draw, no, not mp draw, draw specs is equals to mp draw dot drawing specifications, and there you can write that my thickness is equals to 1 and my circle radius is equals to 2. Let's say, because I'm changing right now, I think initially it is 1 1 or 2 2, something like that. So we are changing it a little bit so that we can see an effect. So once we do that, then we will go to our mp draw over here, and we are going to write our specifications here. So we will say that landmark drawing spec, I think it is the next one, so we can directly write, yeah. So these are the next two parameters, so we can directly write them. So we can write here that it is draw specs, and then again draw specs. So let's run that, and there you go. So now you can see it has changed, and let's say I increase the radius like dramatically. Let's put it 5. So there you go. So now you can see all these weird points, and let's say let's increase this as well to 5, and there you go. So now it is completely blocked. So anyways, you get the idea. So you can put 1 1 here. 1 1 with an HD video is fine, you know, it looks good. But if you have a full HD video, then 1 1 is way too subtle, at least to me. Like, I can't really see the points here. So if you put maybe 2 and you put here 2, then it is more visible. Yeah, something like that. So anyways, you can play around with this all day and you can see which one suits you the best. So this is basically the basic idea of how you can draw. Now that is all well and good, but in reality, when you're creating a project, you need to use these points. You need to know their positioning to actually use them in a project. So how can you get the actual points? Now there are a total of 468 points. So that's a lot, but what we can do is we can at least look at them and we can maybe number them. Maybe you don't know which one is which, so we can put the numbering over there to see which is the nose, which are the starting of the lips, starting of the eye, edge of the eye, and so on. So how do you get these values? So what we will do is, now here we are getting into one face. So face LMS is the landmarks of one face. Now in order to get further deep and find out all the different points, we are going to add another loop. So we will write here for lm in face landmarks dot landmark. We are going to get each of these landmarks and we are going to print it. So we are going to write here print lm. So if I run this now, you will see these are the landmarks. So you get the X position, your Y position, and Z position. So this is the basic idea. So now these landmarks, we are going to first convert them into pixels so that we can use them. Right now they are normalized from 0 to 1. So we are going to write here IH, IW, and IC. I stands for image, image height, image width, image channels is equals to image dot shape. So when we get the shape, now we can multiply it with the normalized values to get the actual pixel values. So what we are going to look at is the X and Y. If you want the Z as well, you can add that as well. But I'm going to write X and Y only. So to get the X and Y value, all we have to do is we have to write lm.x, and then we have to multiply it with the width. And for the height, we will write lm.y multiplied by I height. So that is the basic idea. So now we have our values in terms of pixels, and we can do whatever we want with them. So let's first of all print them out. So we will write here X and Y, and we can comment this part. So let's run that. And if we go back, you can see these are the points that we are getting. So if we want to get the ID for it, well, we can put it in a list and we can check the index of that list. But if you just want to look at it, you can write here enumerate, and here you can write ID. And what you can do is you can write here ID. So that will give you the ID number, and then it will tell you the actual value. So here you can see it starts at, where does it start? Okay, it starts here at 0, and then all the way it goes till 467. So we have a total of 468 values, and each value has an X and a Y point. So a Y, X and a Y number. So here what we will do is we will put this in a list. So what we can do, or let's keep it till here, and then now what we can do is we can create this into a module, and in the module we are going to put it in a list and we will return something. So let's keep the basics still here, that we are getting the numbers and everything, And yeah, that should be good. So let's run it for 2 faces, and let's run it with video number 2. There you go. So if we go down here, you will see a lot of values being generated. That's good. We could also add an enumerate here, and we could write which face number are we talking about, face number 1 or face number 2. But let's forget that, and let's go ahead and do the module. So the idea of the module is that once you create the module, you don't have to write all of this initializations and all of this conversions again and again. So all you need to do is you need to call that function or that method within our class, and that will do the magic for you, and it will return you the values, and you will be happy to work with it. So how do we do that? We right click, we go to new, we create a Python file, we call it face mesh module. Okay. So what we will do is we will go ahead and copy all of our code, and now we are going to convert this into a module. So for the module, the first thing we have to do is we have to write what to do if you are running the module by itself. So we will write here if __ name is equals to __ main, then we are going to run our main function, and we will define our main function here, main, and we will write down our loop inside it. So we will copy this part, actually we will cut it, and we will paste it here, and then we will go here and we will cut this, and we will paste it here, and what else? We will cut this and we will place it above the while. So that gives us the initial part. So if we were to comment all of this, and if we were to run this, it should run. So let's try that. There we go. So this is like we are starting from the scratch. Okay, so then we are going to convert it into a class. So here we are going to write class is equals to face mesh detector. You can write a better name probably, but we are going to use face mesh detector, and then we are going to define our initial method for initialization, and we are going to give in some parameters. Now these parameters will be the ones that are where is it? This one. So for the face mesh, so whatever parameters we have here, we are going to give in to our object. So let me write down here. So we have static image mode. So we will write here static mode is equals to false. So this will be by default false. And then max faces is equals to 2 by default. Then minimum detection confidence is equals to 0.5, and then minimum track confidence is equals to 0.5. So we are going to write these, and then we have to tell that these are the values of this instance. So we will copy this twice, then we will copy this again, we will copy this again, and we will copy this again. So here we will put equals to, equals to, equals to, and equals to, and here we will write self dot this. So we will copy that, self dot. So if you're not familiar with this, I would highly recommend that you check out object-oriented programming, the basics of object-oriented programming. So then we are going to uncomment this, and we are going to write self in front of each of these, and then we are going to write self here as well. And here in the max number of faces and all of this, we need to write our new variables. So here we have self.static mode, self.faces, then minimum detection, let's write it in a new line, and then minimum tracking. So that is the idea. So that is good for initializations. This, if you want to make it a parameter here as well, feel free to do that. I think it should be fine without it. Okay, so next we are going to write a function called, or a method called find mesh face or faces. I don't know, find face mesh, let's say face mesh. And then we will write, of course, self. And then why is it not? Okay, the indentation is wrong. It should be here. Okay, so then we are going to write image and draw. So we will have an option to draw or not draw. So it will be a flag. So we can uncomment this. And we can go back up here. And then we will see what is missing. So this indentation is wrong. So we need to go back. Okay. So then we will just copy this self dot, and again we will start putting the self dot everywhere, and self dot results, self dot mp draw, wherever it's giving an error, just put a self dot. Okay, so that is good. And wait, what happened here? I need to go back. Okay. So that is good, and now we should be able to see our results without going into the returning part. We should be able to see the result, but we didn't create an object, or we didn't call the find face, so it will not do anything. So we need to do that. We will write here detector is equals to face mesh detector, and then here we are going to write here that our image is equals to detector dot face mesh, or is it find face mesh? Yeah, find face mesh, and we will give in our image, and we will keep it true for the drawing part. And here we are going to return our image. So we will write here return image. So that should be good. And let's see if it works. There you go. So now it's working as an object. But the last thing we have to do is we have to convert this so that we are getting our values in return. So that's the main thing. So, and again, the drawing part again is optional. So we can directly put here if draw, then do this. So if I run this now, it should draw. If I go down here and I write here false, it should not draw. It will work, but it will not draw anything. So that's good. Okay, so what is next? Yeah, so now we need to uncomment this. And for every face, we are going to go through every landmark. And through every landmark, we are going to convert it into X and Y. And then we need to store it. So where do we store it? We store it in, let's say, a variable called face. So this will be a list. So we will store it in list. Face.append, and we are going to append the X and Y. So this will be the X and Y value. Now that is good for one face, but we have multiple faces. So what do? We create another list. We call it faces, plural. And this time around, we append, after the loop, we append faces dot append face. So basically, when we are looking for the landmarks, we append the landmarks in the faces. And then once we have that face with all the landmarks, then we append the faces so that we get the final result. So that is the basic idea. Actually, let's put it outside so it doesn't give a random error that it has been used before declaration. So yeah. So in any case, we are going to return faces. So even if it's empty, it doesn't matter. We are going to return it. So that's the idea. And then in the image here, I can write here faces, and that should return the faces. What we can do, we can print here. So we can write here if the, how can we write this? The length of faces. But if we write the length of faces, it will be, yeah, it will be something. Okay, yeah, that should work. If the length of faces is not equals to 0, then we are going to print the length of faces, let's say. So let's see how many faces do we get. Okay, we are printing a lot of things. That's why we are not having a clearer picture. So yeah, let's run it again. There you go. So now it is showing one face. And why is it showing one face? Because we put maximum 2 faces. Why is it showing 1? That is weird. Max faces is 2. Did we say something here? Are we running the module? Yeah, we are running the module. Still saying 1. Okay, let's see why does it say 1. So it should be 4. Oh, this should be inside the loop. My bad. So now it should work. There you go. So now you have 2 faces being detected. And if we go to video number 1, where is that? Video number 1, then it will be 1 face. So you can see here, it's only 1 face. So that is the idea. And then what we can do is to check whether we are on the correct path or not. We can write here faces at 0. Let's see, what does it print? So, oh, actually it's printing the length. No, yeah, actually it's good to see that it has 468 points. So that means we are getting all the points. That is good. But now let's print all the points. It will be a long list. There you go. So now you can see these are all the different points that we have. So this is quite good. Okay, so one more thing we can do. Now, if you're not familiar with which point is which number, then what you can do is you can print the ID number over here. So you can write that CV2, actually we wrote it somewhere. Yeah, why write it again if we have it already? We can write here that CV2.putText, and we are going to put the text of our ID. So let's just write here string ID. And where do we need to put it? We need to put it at X and Y. So this is the X and Y position. 3 is way too big, so we are going to put it as 1, 1. Let's see how that works out. So this is going to print out the ID number of each of the points. Oh boy. Okay, so it's like a matrix. Okay, so that is bad. Maybe we need to look at a video that is more focused on the face, doesn't have a lot of other stuff. Let's see. Maybe this one. Maybe this one will be better. Let's try that. It is number 6. There you go. So now it's much better. So still not that good. We First of all, let's change the maximum to max faces is equals to 1, so we only look at one face. And then let's put this as 0.5. okay, it's going to the kid. I was hoping it will attach to the elderly person, but no, it did not happen. Okay, let's keep the maximum faces as 2, and let's make this even smaller, 0.3. Let's try that. No, that's not readable. 0.5 is, let's try that again. Okay, so I can see 1 is here, 4, 5, then it goes to 195, 151, 9, 8. So yeah, it's a little bit harder to read still. 1.7. Yeah, now it's a little bit better. Here at the edges, you can see very clearly what are the point numbers. So 21, 54, 103, 67, and so on. But in the middle area, especially with the nose, I think I can see 1 here. So 1 is the nose, the center of the nose. Let's try another video. Hopefully we will get something better. So number, by the way, you can read all of this in the paper. So if you go to MediaPipe website, they have a paper listed there, and if you go in the paper, you will find these. You'll find more information on these points. So yeah, no, it's hard to see with this. Maybe if you have just an image and you apply this method on the image, and then you scale it up to see the numbers, maybe that will work. So anyways, this is the basic idea of how you can detect 468 points on a face, and that running on a CPU. All of this running only on a CPU. So that is a pretty amazing task, and the results are pretty good. You can see, let's try out different videos. So we have video number 1. You can see it is pretty good. Video number 2. Actually, let's remove this part. Let's remove the ID, and let's keep it normal. Yeah. So let's try it again. Wait, what happened there? Oh yeah, the draw is false, so we need to remove that. There you go. That is pretty good. You can see it is very smooth. It is very smooth. Yeah. Then let's try number 3. There you go. Even when the faces are a bit far, it is detecting quite well. Number 4, that is good. Okay, when it goes to the side, it disappears. That is understandable. Then let's try number 5. This seems like a Zoom meeting. Yeah, could be used in that. With the frame rate we are getting, it could be used in a Zoom meeting. Okay, let's try number 6. There you go. It's flickering a little bit here. Maybe because they're merging the faces at some point. Yeah, probably because of that. Then let's try number 7. How many do we have? 8? Yes. Okay. That's good. Okay, when she goes down, then of course it will not detect, but as soon as she gets back up, the face is detected. There you go. The person is laughing, and you can see that is pretty good. Okay, so this is it for today's video. I hope you have learned something new. If you like the video, give it a thumbs up, and don't forget to subscribe and share it with your friends, and I will see you in the next one.